This is section 3.3, graph a system of inequalities. If you did the prep, section 2.8, it's just putting all of this together. Instead of graphing one at a time, you have to graph them all together. So I'm going to start with the absolute value, and it gets messy, almost complicated. If you have colored pencils, I would encourage you to use them. I don't have them with me, so you have to just shade carefully. So I'm going to graph -2 times the absolute value of x minus 5 minus 1. So again, this is going to be a shift to the right. This is going to be a shift down. And this is going to be my slope. And this is going to be flipped. So so it's going to flip, it's going to have a slope of 2, it's going to go right 5, and it's going to go down 1. Remember, it's a V. So that's what it normally looks like. So I'm going to go to the right 5, 1, 2, 3, 4, 5, and down 1. And then I have a slope of 2, but I'm flipped, so it's going to look something like this. So there's that. And, whoops, let's call that less than or equal to. That'll make it convenient since I graphed a solid line. And I'm going to check 0, 0. Zero is less than or equal to -2 times the absolute value of -5 is 5. So 0 is less than or equal to -2 minus 1? No. So I don't want to shade. 0, 0 is not in the solution region. So everything under here must be in my solution region. What about x is greater than or equal to 2? Again, if you watched the video, x equals something has a vertical line, because x is always 2. And since I can be equal to, I can also be equal to, this is going to be a solid line. So there's x equals 2. If I'm going to be greater than that, I shade this way. And you're beginning to see the overlap here of the solution region. And then if I'm going to graph this, I'm going to get y by itself. So if I add 3x to both sides, I'm going to have y is less than 3x minus 1. I make a quick table of values. If x is 0, y is -1. If x is 2, 3 times 2 is 6. 6 minus 1 is 5. So I have 0, -1. I have 2, 1, 2, 3, 4, 5. There's that line. It's going to be dashed. I'm really graphing a boundary here. It has to be dashed since nothing on that line works. Like if I picked 2, 5, if I said y is 5 is less than 3 times 2 minus 1, that's not true. It's not less. 5 is not less than 5. So that's why it can't, if it was equal to, that point would count. It's not equal to, so that's why it's dashed. No points on this line would make this true. So again, I have to think about, well, do I want to shade towards 0, 0 or away from 0, 0? So I'm going to check 0, 0. Is 0 less than 3 times 0 minus 1? Is 0 less than -1? No. So I don't want to shade 0, 0. I want to shade below. So let's see if I can do this in a kind of different direction. And again, we're starting to see that overlap is all in here. And then finally, I have 4x plus 3y is less than 12. This is easy to find intercepts. If x is 0, y would have to be 4. If y was 0, x would have to be 3. So 0, 1, 2, 3, 4. 1, 2, 3, 0. Dashed or solid? Correct. Dashed. What's the next step? Test 0, 0 is 4 times 0 plus 3 times 0 less than 12. You bet it is. So I want to shade towards 0, 0. So now you really see this solution region. It's bounded by that line. It's bounded by this line. This line's dashed, remember. And it's bounded by, this guy would start to come in here. So if I picked a point in here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, like 5, -7, oops. If I picked 5, -7, that should make all of these equations true. Any point in here. And again, if I was some kind of company and I had all kinds of constraints, including, my worker payroll, the space in my building, my machine hours, the cost of my materials, that's a whole system of constraints, and I want to maximize profits. There's a set of there's a set of solutions within that region that would satisfy all of my conditions. So just put it all together. Try to identify that solution region as best you can.